Okay, today's lecture is basically on really how to build the full architecture of a DAO. And that means really getting a very sophisticated reputation protocol up and running. And a sophisticated reputation protocol is much more complicated than you might imagine is necessary, might have imagined ever before. And it's partly because making things really work in a decentralized way with technology is not easy at all. So just making the Bitcoin network, the blockchain architecture, was incredibly complex. And we've gone over it for the last several weeks about how redundant everything is, about how everything is checked by everybody is the only way you can make nobody an authority, no single authority, no centralized authority. And so now that we're going to build a more complicated system besides just how do I send a digital token from one person to another person, how are we going to organize the entire governance of a complex company that's decentralized? It's perfectly decentralized. So it takes more. Okay? So today is going to be a little more complicated. So we're going to see how 4 different smart contracts and 2 user interfaces all interact. Now, to do this, we've got a lot of problems we're going to have to take care of. There's the whole issue of we need to make sure that our reputation tokens, when we make them, allow people to anonymously join. We're not going to know who owns that reputation token or how they got it, except if they follow the protocols that we stipulate. So as long as they follow those protocols, we don't care what they were thinking when they got them. They got them. If they have them, it's fair. That's the code is law ethic, right? The code is law philosophy is that if they have the tokens, they have the tokens. They deserve them. And second of all, it has to be open. This network is available to anyone on the planet to join for any reason at any time. Even if they've done something terrible before to the network, well, they can just start and make a new sock puppet account from another place, come in with a VPN, you don't know where they came in from, and that's fine. So it has to be completely open to attack. And it also has to be valuable reputation tokens, or else they're not, what's the point of doing it at all? And if they're valuable, it means it's something that is worth attacking. Okay, so anybody can attack it at any time without any consequence to them, and they're going to want to attack it. So how do you make all this stuff secure is a big challenge, right? And these reputation tokens do also have to be meaningful. They have to actually mean reputation. Just because I call it a reputation token, I can call anything a reputation token. It doesn't make it a reputation token. It has to be actually connected to what the purpose of the DAO is, what the purpose of the group collaborating to do has to be meaningful there with the token. And finally, it's really decentralized. Okay, to make this reputation token decentralized, it means that you can't, it has to be perfectly flat democratically. It has to be like this classical original Greek notion back when they were just screaming in the forum at each other to decide what they were going to do next. And so with that completely open, anonymous, flat, decentralized system, well, this can't happen, right? It's never happened before in the history of humanity. So it's a very big challenge. However, we've never had these new technology tools that made people even dream of attempting this sort of thing. And to begin with, like we started with, this wouldn't work without the internet. You couldn't have a globally open, anonymous people to come in without the internet and without information storage and processing, that all 3 of these things are extremely cheap. Okay, so these 3 things, the information storage and processing and transmission is what the internet is really the trinity of what IT is. So IT is information technology, right? And what that means is just technology for communicating, which is the internet part, for holding meaning, which is storage, and for processing that meaning. So that's everything that is to do with information technology, is those 3 pieces. Just by definition, all of information splits into those 3 pieces. And right now we have new technology that makes it cheap and available for anyone on the planet to participate in these new systems. And that has never been happened before in the world. And that's what maybe makes it possible to have this global fantasy of a global, open, decentralized new organizations. Finally, in order to make it anonymous, we have new cryptography. New, I mean, created in the 1960s. They're actively improving it every day, and it's getting more and more. But we really didn't have that 1960s cryptography available until we had the cheap information storage, processing, and communication. Okay, so now we finally have all these pieces, and only because cryptography has been open source from the beginning. So basically, there's a bunch of heroes out there who are dead or almost dead now who have made this available free. And finally, in 2009, Bitcoin made a proof of concept that these decentralized organizations can actually hold a serious monetary value. And that needed a new type of architecture, a new type of algorithm that didn't exist before the blockchain proof of work algorithm made this consensus possible between a big group of people with nobody in charge. And the last thing is that we finally also have these new peer-to-peer network systems. I don't know, it's paused here.
So I have a question, Professor.
Yeah.
So in order to like start any project, it's better to have a decentralized autonomous organization.
Mm-hmm.
So
That's,
like yeah, that's my question. Is it better to have that like in any project you start in a blockchain?
oh, so if you're asking, do you need a, if you're going to use a blockchain at all, do you need a decentralized system? Yeah, that's the entire point. On a blockchain, everything is terrible on a blockchain. Everything is slow. Everything is very, very expensive. Everything is very, very redundant. You don't want to use a blockchain for anything unless you want decentralized goal. So some sort of decentralized organization is the reason you'd ever use a blockchain architecture, because blockchains, like I said, are absolutely terrible. Just a,
So basically what we're trying to like what these organization is trying to do is come up with a rule for like any project that you're trying to work on in a blockchain then.
um, yeah, so that's the point of this whole course, is figuring out what types of things would you want to use a blockchain for. And especially today, we're trying to explain how would you make a group work together in order to use this decentralized technology in a valuable, meaningful way. And it has to solve all those other problems I mentioned before. Is that a good answer to your question? So
Yeah,
it's really
that
difficult
answers my question.
doing these Zoom meetings because I can't see anybody's facial reaction, that sort of thing. I don't know when I've satisfied the question or not. Okay. So we've got a very big challenge. And so we have this, with this very big, difficult problem here. So how do we create the architecture that's going to allow us to make meaningful reputation tokens, okay, that'll be valuable and that will be secure against all the attacks that can come from anonymous people, from sock puppets, from 51% attacks, that sort of thing. And so, well, you have to have a complicated architecture that's going to move towards security, same way that Bitcoin does. Bitcoin also takes advantage of the fact that it moves forward in time. It doesn't just fix it right away. It gives an incentive mechanism for things to work out, right? There can be forks, there can be those splits in the chain, but eventually one of the splits wins, right? The longest chain wins. The ghost protocol is what it's called. The ghost protocol is the greedy, heaviest observed subtree. Okay, and so those that acronym is basically what explains the Bitcoin's proof of work method, that it converges towards consensus between a bunch of different people competing. So Bitcoin takes advantage of a dynamical system as well, and so is this one. So what I'm going to do here is discuss the 3 different components of the architecture here, and then I'll later explain why it's necessary, and I'll later explain what the consequences are and how it actually solves our problem. And so there's 3 different components here. There's the public people who take advantage of the DAO, but above this red line is the DAO. So the DAO is the members of the DAO, which we'll call the bench of experts, okay, on whatever DAO you're using, whatever group and whatever company is, whatever collaboration you're moving towards, whatever they're experts in, we get these experts together and they'll be called the bench. That's the members of the DAO. And the forum is another component of it, of the 3rd component of the whole system. And the forum is just the history of the DAO, everything that's ever happened, everything that means anything. And the DAO experts, the people in the bench, are the ones who make the posts that create the forum as time goes by. And the forum itself tells people what their reputation tokens are. It tells you whether or not you are expert 1 or expert 2 or expert 3 or expert 10 or expert 100. Then each one is going to have a certain number of reputation tokens, and that will be dictated by what they've done in the past, in the history. So the forum is the history of the DAO, and the reputation tokens is the accounting of what their history is. And each person has a certain number of reputation tokens. And by the way, you'd want reputation in multiple different things. We're not going to get into that. We're going to talk about one expertise. But you'd want, in any reputation system, you don't want one notion of reputation. People who are good at baking bread are not good at fixing motorcycles, or they may be, but not necessarily. So you don't want reputation to just mean one thing for everything, rather. It doesn't want to mean everything. You want multiple different types of reputation. And so this is just how we're going to explain how to make one type of reputation. And so what is the system here? Yeah, go ahead.
Yeah. So Professor, when we say DAO, right? So a DAO is like kind of let's take an example of the chit fund as a DAO, right?
Mm-hmm.
So when we have the DAO in place, so the bench you're talking about, like you're telling different expertise 1, 2, and 3. So how do they get the reputation tokens in that example? Like we have the DAO, we release it to the market, and you can use the DAO and create your own chit fund, and I can use the DAO and I can create my own chit fund. So how we contribute and how does the forum helps to get the reputation tokens for the DAOs?
Yeah, well, that's what the entire next hour is supposed to discuss. It's not easy. This is very, very difficult. And the chit fund is particularly difficult to explain. So we might want to imagine, in this case, something simpler than the chit fund. Something, so I'm just making one up off the top of my head, is, say, for instance, ride sharing, like being Uber. We're going to make a decentralized Uber app. And now these people are just, these people are drivers, right?
Got it.
In the Uber app. And there might also be developers like you are. It might be the computer programmers. But you'd get one type of reputation for being a driver, one type of reputation for being a computer programmer for the DAO, right? Okay.
Yep.
But let's just stick to one idea and get all the way through it. It's just for driving. Okay. Sure. So we're going to have the reputation token for driving, and each people is going to have that reputation. They're going to have different amounts of reputation based on how much they contributed to the DAO, right? And each post will be, this is proof that I drove somebody and I followed the protocols that everybody had agreed on to be a good driver in this DAO. And so what we're going to do now is have all that history in the forum of all the posts that prove that they did the work properly. And so that's one thing, is they're going to post there. And then they'll get a reputation token based on whether or not they drove properly. Well, how do you know whether they drove properly? Well, there needs to be a validation pool. Okay, so this is the main DAO smart contract that I'm going to get into in great detail. It'll take me 15 minutes to explain how we measure whether or not the person drove properly or did whatever task it is that the DAO does. Okay, and so that's going to be our major smart contract for the DAO. But I also have to discuss the connection between all these 3 different, let's see, all these three different pieces of my dynamical system. So the forum is one piece. That's the history of the whole contract. The public is another piece. They're not part of this DAO. They're not part of the organization, but they use the organization and they're essential for making the organization work, because you want the people in the public out here to actually pay fees to the experts, right? They're driving the reason for the DAO's existence, is they're giving money here, but they're not members of the DAO. They're outside members. But the members of the DAO are going to create the forum with the history of everything they've ever done. And the forum is going to include, first of all, the reputation. You'll do the history of that reputation, the evidence that they actually do what they say they'll do. And it will include the smart contract language. That's the newest smart contracting language that they can use to engage the bench. So there's one smart contract, which is the business smart contract for the public. Another smart contract is to validate whether or not the business was done properly and to give people reputation tokens. And those are the two main smart contracts that we need to build. But there's two more that I'll have to get into as we go through. Those are the two main difficult ones to figure out, though.
In this example, the forum, is that just a like data in this representation, or is that people?
It's a list of posts, of posts, but it's not just a list of posts. There's a smart contract that goes along with whether or not they've been validated. So it's a list of posts that have also been voted on, is what we're going to get to. That you can tell whether it's a good post or a bad post, in like a Reddit upvote or a Stack Overflow thing, that you use your reputation to say, yeah, that was a good post. Okay. But we're going to make it meaningful. Okay. And that's what the goal of the entire lecture is about, is how do we make these posts, these lists of history, this database of information, how do we make each of the pieces meaningful or unmeaningful? How do we judge them? And that's what the validation pool smart contract, the main DAO smart contract, is going to determine.
Professor, I got a question.
Yep.
So for the public, or like you said, the people that are outside of this, of the DAO, I just want to get a clear picture. Like, are you talking about users of the DAO?
Yeah, they'd be the users of, like, they'd be the riders in a ride sharing app.
So they're not the drivers, in case we were talking about like something like rideshare.
That's
right.
right.
They are the ones that are buying the rides.
That's exactly right. The experts would be the drivers in that case of that particular DAO, and the riders would pay for them is the public. And see, they pay the fees right here towards the experts. So they pay the fees toward the drivers, and the drivers drive them, and then they prove that they did the driving, and all the other drivers have to verify that they did the driving properly.
But the public still can influence this, forum, because they are the ones that receive the service. Are they allowed to make, say, or have a say about their experience? Would that affect how the validation pool works?
That would be very important for any DAO to determine, to put that in there. They would want to use that feedback to determine that, right? But technically, no, the public isn't allowed to do anything in the DAO. The DAO is just determined by what the experts do. But what do the experts do? They're going to want in their validation pool to include information from the public, a review, that sort of thing. But they're going to decide how to interpret that information based on their DAO, based on the circumstances, based on how business is happening. So certain things are going to change all the time, but certain things, as I'm going to describe, are hard-coded. This is just how this will work. So the validation pool rules of that smart contract will be very static. The smart contract that the public uses, we're going to change that all the time to determine how much we're going to use of public information and how much we're going to use of other things, other economic factors that change all the time, like how much we're going to charge for the rides, what sort of hours, that sort of thing.
Thank you. Thank you for clarifying it.
Yeah, sure. Okay, so I've kind of gone through all these things, but the forum is going to have a list of what is the smart contract that you're supposed to use. And the user interface is going to find the smart contract in the forum that's the newest active one. And then the users will use that smart contract to engage the experts and find the fees and figure out whether they want to use the smart contract or not, right? So this is a capitalist situation, right? Where these guys are choosing whether or not to pay for the fees that will go towards the experts over here. So they get those templates from the forum, and then they'll engage the smart contract they find there. And the business smart contract that the public uses is different. That's the second contract, different than the validation contract. That business smart contract will encumber the fees from the users, from the customers, and they'll send that fee to the platform, okay, to the DAO. That business smart contract will also call a random expert to do work off chain. And it will also conclude the smart contract with everything that entails, which I'll get into more details of that in a bit. And then, so the fees got sent to the bench of people. And then the person did that work and finished. This expert was called with that smart contract, and the expert did work off chain. In other words, in real life, right? They're not going to put any of that on the blockchain. They're not going to use a smart contract to do the work in real life. Now that smart contract is finished, when that person finished the job, they did it either well or they did it poorly. What that person is then going to do is that expert is going to post the evidence of what they did to the forum. They're going to show that smart contract was concluded, however it was concluded. At that point, you could get the feedback from the customers. It depends on how you write this business smart contract and how it then posts evidence of work to the forum. So at that point, we can choose to have customer feedback in that place. By the way, this is all open. I mean, it's an abstract architecture for this. Everything is variable. You can change it, and you will change it based on what you want to apply it to. Okay, so now the expert sends their evidence to the forum of what happened, and that gives an opportunity for people to provide other comments. So the other experts judge the post of evidence of what the work that one expert did. And then they could debate it if they needed to. And then the validation pool smart contract will be engaged. And what it does is it takes the information that was given, and everybody is going to vote on whether or not the post of the evidence of work was good or not. And if it was bad, then the expert loses reputation points. If it was good, then the expert gains reputation tokens. So that's what's going to happen. And also there's going to be policing going on, so other people can gain reputation tokens. If they show that this person did a bad job, then they will gain more reputation tokens. If they showed you did a good job, they can gain a little bit of reputation tokens. But we'll get into that in a bit when I go into the full explanation of what's happening with the validation pool. Okay, and then the fee that was given by the customers is not given to the person who did the job. So this is a major issue that a lot of people have a problem with, especially if they're raised in a centralized business environment, which every one of us is, right? But the idea is that the money that was paid by the fees is not sent to the expert who did the work. That's a frustrating idea. What the expert who did the work gets is new reputation tokens. They get the majority of reputation tokens if they did a good job, which they should always do a good job. And if they did a good job, they get the new reputation tokens, but they don't get the fees. Everybody shares in the fees based on how much reputation you have. So if expert 1 has 50% of the reputation tokens and expert 2 has 10%, then expert 1 gets 5 times as much of the constant salary that's brought in by the DAO. And the expert who actually did the work doesn't get the money directly. They only get money based on how much reputation they have. So it's a long-term goal here. You don't get the immediate value.
So in that case, the revenues kind of accumulate, right?
Exactly.
And they're not being used towards any of the experts. I wonder where, what is the purpose of accumulating them?
Accumulating reputation tokens or salary?
No, the revenues that came from the businesses, the business that customers brought in.
Yeah, the revenues just come later, right? Like if you made reputation by doing 10 jobs last week, now you have 10 extra amounts of reputation tokens. Then later, as the fees come in from the business people, from the business smart contracts, as those fees come in, then you get paid.
Oh,
And
I
so
see.
what you get paid in immediately is most reputation tokens, but later you get paid relative to how many reputation tokens you've built.
So you might not get any fees. I mean, you might not get any money out of those fees if you have a bad experience, right? I mean, or if you
Exactly.
didn't give a good service.
Exactly, you get zero.
Okay. No, that's good.
Right, it's meritocratic, right? If you improve the DAO by doing good work, you get reputation, and later on you'll get paid if the fees come in. And the fees will come in if the forum proves that it's a good place where people get good work. And so then the public chooses to engage the forum and uses the smart contracting language and pays the fees, which eventually go to everybody who has contributed to making a big group that is actually valuable. So I want to get
I have,
yeah,
I have
go ahead.
another question, Professor.
Yep.
So are these experts like, is this all anonymous, or like do expert one know expert two, or like do they know who's in the forum or like who's in the bench?
In this abstract example, everything is completely anonymous, and you can have 1,000 sock puppets if you want. So it's completely sock puppet resistant. That everything you do allows complete anonymity and allows sock puppets if you want to. In fact, it encourages sock puppets. However, to answer your question a little more bluntly, reality shows that when people work together, they know who they are. Whether or not they know their name, like so for instance, the best example is Wikipedia editors. They know each other, even though they don't know each other's name, maybe, if they have fake names. When somebody hacks somebody else's account, they know it instantly. It's like, what? You're not 783 ABC, right? 783 ABC wouldn't write like that. So it turns out that, your name is not that important when you're in a DAO like this and you collaborate with other people. You'll get to know each other really well. But the fact is, they're all anonymous. So for this particular architecture I'm describing, I'm going to try to demonstrate how it's valid, how it's safe and secure, how it's algorithmically robust and rigorous, and that you don't need to have identity. You can be completely anonymous, and you can have multiple different accounts if you want, and that it's the same.
Yeah, got it.
Okay, so let's get more into this validation pool smart contract, because that is the main smart contract that determines what the DAO is. So this smart contract will tell people whether you're in it or whether you're out, because this validation pool is what determines who gets the reputation tokens and why and when. So let's explain that a little more carefully, the validation pool smart contract. And so what this smart contract does is polices the evidence of work posts that are sent in. So when an expert finishes their job, what they're going to send in is evidence of work and an availability stake. So I need to explain that. That's the third smart contract, is that the experts are going to have engaged their own smart contract to say, I'm ready to do work. And this is the simplest smart contract of the four. And that availability smart contract is simply to say that we are going to, I'm just saying that I'm available to do work, and I'm staking my reputation on the fact that if I do work, I'm going to do it properly. And when you engage that availability smart contract, there's going to be an opportunity for the business smart contract to randomly select you. Okay. So at that stage back here, I'll go into that deeper in a second. When the right here, when the business smart contract calls an expert to do this, then the random expert is called based on whether or not they put in availability stakes. So all the experts who want to do a job will engage a smart contract, and they will encumber their reputation tokens to say, yeah, I'll do a job, and if I don't do it right, I'm going to be punished. If I do it right, I'm going to be rewarded with extra reputation tokens at the end. And so I'm sorry, I'm distracted by what's going on here. Okay, so that's the availability stakes. Any questions about it? I'll get to explaining that a little bit more in a bit, hopefully. So in order to be randomly selected to do the job, you are going to put in your availability stakes. And when you put in your availability stakes and you get chosen randomly, then you finish your job and you post your evidence of work. Okay, and that's the beginning of what the validation pool is going to do. After you've posted your evidence of work into the forum and your availability stake is encumbered in the business smart contract that interacts with the validation pool smart contract. So those are the three main smart contracts. And this is the hardest part to get all that understood as to how it all interacts with each other. Okay. When they do their evidence of work, their availability stakes go in as, we're going to stake it on basically a bet, but it's basically a vote. They're going to say 10 reputation tokens, their availability stakes are voted up. I'm saying that the post that I did for my evidence of work, I'm voting that it's going to win, that it's a good post. And so that's automatically sent in as positive. The next stage of the validation pool is that it takes the fee that was collected by the customers in the business smart contract, and it mints brand new reputation tokens that didn't exist before this in proportion to how much the fee cost. If you paid $100 on a driving app for your decentralized DAO that runs the ride sharing, if the customer paid $100 to the person, it gets sent into the system, not to the person, and the system mints 100 new reputation tokens, okay, that didn't exist before. And what happens with those new reputation tokens is that it splits them 50-50. 50 of the new reputation tokens are given as upvotes, and 50 are given as downvotes. So the validation pool is fair right now, but the 50 upvotes go to are staked in the original poster's name, who did the evidence of work, the original worker who did the job. So those new 50 tokens are in the original poster's name, and if he wins 50 new tokens. Okay, and that's the reward for driving. Now, 50 tokens are also staked against it, so that now at the next step, other people can vote against it. Did I hear anybody saying a question? Please don't hesitate to interrupt further, but I still have to explain. Now, after those are done, there's going to be a period where you can make some comments on the post. So other people can make their comments on the post and say, yeah, that was good or bad. And they're signaling whether or not it was a good job. Now, what they're also doing is policing the work of the DAO, making sure that everybody's doing things right. And after they made those comments on the post, then everybody's going to either upvote supporters or they're going to downvote. And they add their own reputation, 3 reputation tokens to say, yeah, that was a good post. That was a good job of doing the job that we do as a DAO. And other people will add to it, and they'll say also upvote. But then some people may disagree and say it was a bad job. So they'll join the 50 new tokens that were downvoted, and together they'll have in this particular case, there were 9 reputation tokens staked saying that was a bad job. And there were only 7 extra supporters, plus the 10 that the original poster did with the availability stakes, makes 17 extra, so they win. Now, in that case, whoever wins splits the loser's stakes. And so this is all just arithmetic, by the way. It's a lot simpler than it sounds, right? This is something that bookies do in a way more complicated way than we do, right here. And so the winners, in this case, the upvotes, take the loser's stakes, including the 50 that were also newly minted, and they share them proportionally to how they voted to police this. Now, the original poster should get the most of the reward, but if other people have more reputation, they should put all their money in. And that's the gist of the whole validation pool. In the end, they get their the reputation tokens that were newly minted are split in this way. It's a fair system. And inside of the system, the original poster gets a chunk of them, at least half of the newly minted tokens, but the other half can be split amongst the people who are policing it. Now, and so then all the detractors lost all their tokens that they staked on it, and the supporters and the original poster win the money.
So, Professor.
Yep.
Sorry. So, I mean, the validation pool here, I think, not sure. So do we need to do like half and half? Maybe like it gets more complicated, right? Based upon the DAO we are creating, right? It cannot be always like 50 for upwards or 50% for downwards like that.
Right. So at the very beginning here, you're asking if there's another option of like, so the reason that we minted 100 reputation tokens in proportion to the fees. First of all, that stage is very important. That reputation tokens are only minted. The only time they ever enter the system is when money comes into the system. So that's what makes the reputation tokens meaningful, is that there's proof that that reputation was connected to something grounded, actual cash, actual money, right? So that's where you get the meaning out of the reputation tokens. Second of all, when we make the reputation tokens, we mint them, we stake 50 up and 50 down. That's just to make sure that the vote is not skewed one way or the other. We don't want to encourage bad behavior and then, well, we should all vote on the good side because that person's going to win anyway. And so the 50-50 is just there to determine, just to make sure that the vote is fair and you wouldn't be encouraged to be voting one side or the other automatically. So just out of fairness, we split it 50-50. However, this is one of the major parameters that can be adjusted in this as we go forward and make these things more complicated. I didn't want to get into it right now, but you wouldn't have to share the 50 that are downvoted. You could just throw those away if you didn't care about policing. The 50 that go into downvoting, in this case, those 50 downvoting over here are going to be, they're not assigned to anybody right now, right? Nobody gets them. The 50 that were gone and upvoted were assigned to the original worker. So that original worker, that's their reward for doing the work. But the 50 that went for downvoting is going to be split amongst the people who did the policing and the original poster. But the people who do the policing would normally get all that value. And so that 50 right there is really policing money. And if your DAO doesn't need that much policing, then you wouldn't actually put this 50 in. You wouldn't actually share that 50 amongst the people who won. If you need more policing, then you'd maybe mint more than 50 and share more than 50 at each point. So it depends on the situation for your DAO, like depending on the circumstances of the economic environment. Like are people attacking the DAO and trying to destroy it? Well, then you'd want to really encourage policing and making sure that people do comments on things. If it's safe and secure and nobody's doing anything, then we shouldn't pay that much to police. We should just pay enough to police to make sure that somebody's participating. Okay. just make it minimally necessary.
That helps, Professor. I mean, the policy now it makes more clearer, right? Why we need that reputation taken for the policy.
Cool. Okay, so that's a big part of all this. Is this whole system is that the validation pool determines how reputation tokens are minted and where they go. And so in other words, that's the DAO's smart contract. That's the one that determines what the DAO is in the long run. So the experts send their posts over here to the forum, then the forum holds the history of everything that's ever happened. And the forum is what is the history that's publicly available for anybody to look and get the smart contract off the forum to use it. And then they pay the fees to the experts, the DAO members who do the posts. Okay, and they get the reputation tokens if the validation pool comes out in their side. In other words, if the people all agree that what they did was good, well then the person who did the work will get reputation tokens. If they don't agree, then the person loses their availability stake reputation tokens. So we have those three smart contracts that I was talking about: the validation pool smart contract, the business smart contract, and the availability stakes smart contract. The validation pool smart contract is very finite, and it's just arithmetic of figuring out how betting pools work. And the business smart contract will always evolve to change to make it more attractive to the public. Like, we do this, and here's how you can engage us, and this is the prices that we charge for the work we do. And so this business smart contract will forever change. Okay, this is constantly going to evolve, and you'll have a new one in the forum as each new iteration happens. Now, I mean, it'll stay the same until the DAO wants a new smart contract to attract more customers, but this one's more variable. The validation pool smart contract is pretty static. You can change some parameters, and I wrote a whole long paper on what each parameter means and what the consequences are for how it will change the DAO, because it will motivate different behavior. So the question is, I'm getting off on a second order tangent here, but depending on your DAO's values, you're going to want to use certain different types of parameters in the validation pool's choices here to motivate certain behavior. Okay, and it just depends on what your DAO wants to do as to how it sets up the validation pool. And finally, the third smart contract was the availability stakes, which is a very trivial smart contract that each expert engages just to say, I'm ready to do work. Okay, that just emits a signal that says, I've encumbered my reputation tokens and I'm willing to lose them if I don't do a good job, or if I don't show up when I said I was going to show up. I'm available and I don't do it.
So, Professor, about that one contract, the availability one.
Mm-hmm.
So you said there's some randomness about it. Just to make sure I'm understanding this right.
Right.
So the randomness comes in, when we have people asking for service, right? And then the experts don't get to choose, right? They randomly get picked and assigned to a customer, right?
This is an abstract situation. So I'm just putting that in as something that we can do that would also maintain decentralization. You don't want one expert controlling everything all the time, right? So randomization just seems like the fairest choice, and also the one that's resistant to sock puppet attacks. So if we just went and cycled through the different experts and said, well, this one goes first, then this one goes second, then this one goes third, etc., then what I'm going to do is I'm going to set up 10,000 sock puppets. And that means I get to go for the first, second, third, fourth, up to the 10,000th time. And so what you do is you proportionally choose who's available. So if this person puts in 50 availability reputation tokens for their availability smart contract, and second person puts in 10 if this one second person puts in 10 reputation tokens in their availability smart contract, then the first person put in 5 times as many, so is 5 times as likely to get the job as the second person, just because it's going to randomly select amongst all the reputation tokens that are out there. And so that's a variable choice.
Yeah. So it is still kind of, it depends on how much they are putting into staking out for the tokens, right?
That's right. And so a more powerful person, someone with more reputation, is more likely to get more reputation because they're more likely to get a job. And that's a danger of centralization, right? That you can concentrate power by getting more and more reputation. That is inevitable in any natural situation. However, this system still encourages decentralization because people can only do so many jobs. So it depends on the situation, but if there's 10,000 jobs, one person can't do all of them. And so the more powerful the DAO gets, one person can't do all the jobs, even if they had half of the reputation of the entire network. Well, they can't do half of all the jobs if it's a powerful network. So it actually isn't that centralizing of a force. They only get reputation for the jobs they do. And so if people work, then that's a decentralizing force here. But the fact is, if you have more reputation, yeah, you're more likely to get a job than somebody who just started. You don't want somebody with zero reputation showing up and getting equal number of jobs as the person who's worked for 20 years, right?
But then I go back to the ride sharing example because we used it. I think there's a little of a contradiction here because in reality, in a centralized setting, we got the customer that is choosing who they want to ride with.
Right.
And here we got the opposite, complete opposite scenario where the customer does not really have any control of that. They just say, "Oh, I want to ride," and then the system picks one randomly and assign it to them. Is that how this working? I mean, I know it's all can be changed, but
yeah. So no,
okay.
That's exactly right. Everything you say is exactly right. And especially the last part where everything can be changed. So this is a generic system for all possible DAOs, right? Of how they make reputation. And so any particular DAO that we actually create is going to change every single thing that I just described, right? They're going to tweak it to adapt to that particular organization for what they're collaborating in order to do. So for a ride sharing DAO, the smart contract that they engage is going to be more complicated than what I just described. It'll have your availability stakes, and it'll also include, when it makes the decision of who to pick, like the location of the person, obviously, like whoever's closest. And it might also include what the customer wants. They'd make this business smart contract very complicated. So like I said, the business smart contract is going to evolve all the time, and it will become more and more complicated as long as the programmers choose to make it more complicated and more sophisticated, and as long as they can improve it. And so one of the improvements you just definitely hit on is like, you're not just going to pick a random driver to engage that. You're going to let customers have choices. You're going to let location be a factor. You're going to do a lot of different things than what I just described, right? So you're exactly right. This is not the beginning and end of, of all possible companies.
Yeah, that completely makes sense, Professor. Thank you.
Cool. Okay. So here I just want to quickly review everything we did and talk about why each thing is a necessary component. So it seems like there's a lot of different working pieces in here. And can you throw any of them out? Well, I'm kind of want to argue for each piece real quickly. Why do we need a forum? Why even have this architecture at all? Well, the forum or something like it has to happen. In order for this to be a true DAO, it has to be open. It has to be this place where everybody can broadcast what happened. You have to be able to, if nobody's going to be in charge, there's no secrets, right? We have to be able to see what happened in the past in order for that reputation to be meaningful. And so you need some place to advertise the history of what's happened and what they claim to be about. So the forum is the history of what happened, but it's also it's an advertisement to the public of, here's the smart contract we use, here's what we promise to do for you, here's the protocols we use. And it's also an advertisement to the other members of, this is what we do, so this is what you have to follow. The validation pool is a necessary thing because how else can you govern? How else can you police things except democratically? Basically, you want to vote on things, and you need to vote on a weighted democracy. So it's not a flat democracy. It's not a one person, one vote situation. It's people with more reputation get a bigger vote. And that's necessary if you want to have the anonymity and openness. If you want to prevent sock puppet attacks, that's part of why you'd want the weighted reputation, the weighted democracy. The other part is for meritocracy, that people who do a better job should have a bigger say in the network, in the organization. The fact that the new tokens were minted when the fees came in, that's when the new tokens happened. That's just, like I said, to lock in that the tokens actually mean something, that the reputation tokens aren't just fake reputation tokens that you print 1 billion of them and hand them out randomly. You actually only print them when the fees come in, and then it has a grounded meaning. The reputational salary is a really big part of this. That's a sticking point for a lot of people that I explain this to. That's maybe the most radical piece of this, is because it's not the way we normally think about things, but this is really necessary to make the reputation also meaningful. That you want actually the reputation, you don't want the fees. You want to build more and more reputation. When you have a system where you're trying to get reputation, then everybody's going to protect the system more than they would if everything was just about money. So when you have reputation, it means you have this future investment in the system, in the organization. And so that's part of why you want to make sure it's a reputational salary. Other people argue, well, what do we do, half the money right now and half in reputation? You can do that. There's lots of choices you can do here. You don't have to just make the reputational salary. But I think it's really essential for making the organization stay cohesive, is that reputation is the thing you want to motivate yourself for instead of the actual money. There's a lot of game theory I can talk about later as to why reputation is the right incentive for keeping a group together and for policing it, as opposed to just money. Money is a dangerous zero-sum type of goal, whereas reputation is a positive sum goal. People can invent reputation just by behaving well out of nothing, right? Two people come together and do a good job, well then genuine reputation is invented. Whereas money is just zero sum. If you leave a negotiation with some of the money on the table, the other people get it, you don't get it. So when you're gonna go in business and it's all about money, then it's cutthroat. You're just trying to get as much money as possible. But with reputation, you want to work together, you want to collaborate. Anyway, so it's a very important piece of the whole idea of having a reputation mechanism, is to make the salary reputation weighted. Now, finally, I didn't really discuss how the forum is going to change as time goes by, because what if somebody gets past this? So there's this last piece is very much more complicated, is that the forum can change its value as time goes by making comments on those old posts, on those old statements in the forum. And when you review those old comments, that can change the value of the posts. So I don't want to say too much about that. I don't know what time it is here. Cool, I've only been going for an hour. But I'm assuming we're going to break a little pretty soon. Let me try to just plow through this part. So when I'm looking at the forum, here's some nasty bit of mathese technical jargon, okay, is that the forum is technically what's called in graph theory a weighted directed acyclic graph, a WDAG, okay? And that means something to mathematicians and the experts who study graph theory, but you don't have to worry about it. It's not that tense, but it just means I'm not trying to blizzard you with jargon right here, but it just means that there's a good structure that's computationally efficient. And so if you know about graph theory, then you can apply a whole bunch of theorems to it. But anyway, what that means real quick, because it comes up a lot in blockchain, because the blockchain itself is a weighted directed acyclic graph, okay? And so in this area, in network theory, you're going to hear a lot about this stuff. So just to explain what a directed acyclic graph is. Okay, well, first, a graph is just a collection of a bunch of dots and arrows, a bunch of vertices and a bunch of edges. In our case, the posts, each post that you put into the forum is considered to be a vertex. And then each edge is going to be a reference where another post can lead to your post. And so a graph with cycles is one where a vertex is directed to another vertex. The second is directed to a third vertex, and the third vertex is directed back to the first one. So that's a cycle. Well, in our forum, there's no possibility of cycles. When I do posts, the idea is that each post will only be able to reference to this one, and this post will not be able to reference back to it because it's going to be ordered in time. And so it's an ordered field here. Anyway, and so we get these weighted directed acyclic graphs. So the directed acyclic graphs means there's no cycles inside the posts, and each one references it. The weighted directed part, the weighted part, is that each of these vertices has a weight to them. And so what I'm talking about is, say I did a post down here that proved that that said, here's how I think we should run the organization. We should do a new smart contract for a business smart contract to engage the customers. And this other person comments on my post. And when the person comments on that post, people judge it as to whether or not that comment is correct or not, and that will lend weight to my post. Okay, and it might lend a lot of weight to it, or it might lend less weight to it, depending on what it is. And maybe it's a detracting post. So maybe this post said, this post sucks. And so I'm putting a negative post on it. And so this one will suck away value to that post. If people upvote this one and give it a value of 3, and it's that negative, well, then it'll hurt that one that much. And that's how, so I don't want to really get into this, but that's the last piece, is what is the smart contract that's going to go on for determining the actual value of the reputation tokens that goes into the reputation in the whole DAO. And so there's a little bit more that goes on to this thing. So that's the fourth smart contract that I don't want to get into too much today. Okay, but that just illustrates the last piece of the fourth smart contract in the forum here, is that there's going to be a smart contract that dictate how the posts are all interrelated and how you can review old posts with new posts and say, yeah, I don't think that post that everybody thought was so great is so good. Let's reevaluate the importance of that. And that reevaluation allows the DAO to evolve in a more healthy manner. Okay, so that's the whole gist of it. The main there's 4 smart contracts. The smart contract that determines what is the DAO, how do you make reputation tokens and who gets them, is basically the validation pool. The business smart contract is the one that, again, the DAO creates and they agree to put into their forum, but that the public uses. And they choose whether or not to engage it. They choose whether or not to put their fees into that and engage a member of the DAO. The third one is the very simple availability smart contract. That's a trivial one to write, and it's not going to need to be updated too much. It's always very simple. It's just, are you available to do work, and you have to encumber your reputation tokens to prove that you're available to work, and you'll get punished if you don't do the work properly after you promise to do it. And finally, that's forum smart contract that I went over way too shortly as we're getting later on in the night. But then there's also 2 user interfaces that you need to deal with: the public or customer user interface, and then there's also the DAO member, the experts user interface. So there's 2 different user interfaces you have to build to interact with those 4 smart contracts. And there's just different details that are kind of obvious as to what the public user interface is going to be, as opposed to what the member of the DAO user interface is going to be, and what it has to do in each of these cases in order to interact with those other 4 smart contracts. Okay, so the public user interface is going to interact with the forum smart contract in order to collect the business smart contract that's current. The public user interface is going to have to interact with the wallet to encumber fees so it can give them to the DAO, so they can give them to the business smart contract. And it'll also have to do off-chain communication. So the public user interface is going to do all the heavy lifting of computation, right? All the real smart contracts want to do almost nothing, but communicating with a chosen expert, you don't want to do that on chain. You want to make sure that's off chain. And so all the heavy programming is going to be in both of the user interfaces. The smart contracts, they're going on the blockchain. They don't want to do hardly anything except arithmetic. Very, very simple arithmetic too. And so this validation pool is just simple arithmetic. It's just weighted averages in order to determine where the new reputation tokens are that mints reputation tokens, and then it distributes them, right? That's all that the blockchain is good for, with a little bit of logic. The business smart contract can evolve to get more complicated, but it has to be very, very simple here. It has to interact with the user interfaces. But the smart contract itself should be simple, and the availability smart contract, crazy simple, right? None of these want to be at all complicated. The forum smart contract is a problem because you don't want to pay $5 every time you want to make a post on the forum or even comment on something, right? So whether the forum smart contract is a smart contract or if it's mostly off-chain, maybe on IPFS, that's an issue. And today, the forum smart contract should be off-chain. Maybe in the future, when we make things more efficient, then you'd put the forum history on chain. You'd want that on chain because you'd want to know the entire history of the forum, but maybe you'll just put headers from the forum of like not the actual full content of proof of work, that sort of thing. You just do addresses. And so you do very simple things in the forum that are just headers. And then it can actually be on chain and it can be checkable for all future time.
So, Professor, I'll take you back to the forum, and I said I want to ask a question about implementation here.
How far back? Like,
just what you just talked about, like the last thing you were talking about, which is forums.
okay.
You mentioned IPFS, right? Which is like, as far as I understand, is peer-to-peer storage, right?
Yep.
And I was going to ask you about storage before. So the forum basically, yeah, definitely holds data. Are we using any form of a database? Are we sticking to this IPFS thing because it's peer-to-peer, or I'm trying to understand the storage part.
Right. So the forum is the stickiest issue. And for today, meaning this year, I would recommend putting all of the forum on IPFS. The problem with that is just that it's deletable. But the benefit of that is it's very cheap. So IPFS is actually practical today. Well, when I checked it 6 months ago, it was very, very cheap. It was almost free because there's still just a lot of people with white hats, basically, trying to make IPFS work. So you can watch movies off of IPFS. You can do tons of information. You can download books and everything else. And it's cheap. But so that's what I recommend right now. And the other thing is it's also decentralized. So it's a solid, provable, decentralized situation. If your DAO hosts a website that runs this forum, well, then somebody has to be in charge of it. One of the people in the DAO has to hold the keys, has to hold the passwords to the website. And that makes it not decentralized, right? Then any one person could take down the website, that sort of thing. Now, there's ways around that. Like, as long as the website's going, many different people can clone the website and they can put it up with different people at any time. And so nobody's really in charge of it. If somebody doesn't actually do what's required, then other people could pop it up. So nothing's perfect, nothing's ideal. But in this class, we're actually making proof of concepts type of things, right? So we're going to try to make every different aspect as decentralized as possible and criticize anything that's not. So if we actually use a normal website, then the owner of the website is just to be criticized as a centralization vector, right? But mostly, so that's the idea right now, is to make a IPFS site for the forum. The problem with the IPFS site is that it's not going to record it for all time necessarily. So some of this information could get lost, again, theoretically. In reality, no, IPFS stores stuff very cheaply for a long time. And so that's not a practical problem to put it on IPFS. But theoretically, it's better if we put it on the blockchain, because then it's guaranteed to be available for all future eternity, as long as the blockchain survives. And so theoretically, we'd want a blockchain to hold at least the headers of all these posts and the connections, each of the references from one post to another reference to another post. And that's enough information. You can store it on a blockchain. And then they also just reference some other website maybe that is maybe in the future taken down. So such issues are complicated, thorny issues, and the forum is definitely the most complicated smart contract to deal with, especially if you're going to add that last case that I was describing, which is extra, by the way, to make the references to other posts and allow review. I forgot where I put that. That's after all this stuff. But the last necessity of a good reputation token was that allowing review of what the value of reputation means. And that's only possible if you make a sophisticated forum smart contract that allows references and weighted references and voting on the references and voting on the other comments, the other posts that comment on the comments and those comment on the comments. So that part gets thorny, but again, it's still certainly doable within the technology we have right now in many different ways. But that's the last thing you'd want to worry about. And important, but still.
Okay, so, but databases, like conventional databases, are pretty much not a good choice for this. I'm kind of seeing the picture why. So
yeah, again, the only reason is centralization. If you put it in a conventional database, whoever owns the database controls in some degree the DAO. They can stop the DAO. They can destroy the DAO. They can bribe the DAO, right? They can hold it hostage because they own the DAO's history. That's only theoretical, again, right? Most major centralized places wouldn't do that to a rideshare DApp, right? But it's a centralization threat, and so theoretically it's bad. Okay, and so we just want to recognize that in this class. We don't actually have to. In a practical world, you do lots of things that aren't ideal. You have to. That's just the way it works. Okay, any other comments or questions about that?
The last comment you just made,
yep.
It's such that no system is perfect in the real world, right?
Right.
Essentially, okay.
Yeah, that's not deeper than that, right? that's the reality. So just a few things to talk about is as we're thinking about this architecture that I'm trying to describe, this convoluted thing. By the way, it helps you understand any DAO that's out there right now, any more sophisticated group that you can go analyze, is to think about these interactions that I just described, that we break it down into these three components of, like, how does the public interact with the DAO? How does the DAO operate inside of itself? And how does the DAO record what it did in the past? Those three components are just basic components for analyzing any decentralized autonomous organization right now. And so they don't always do it this way. They certainly don't, okay? There's a million choices you make each time. And to me, most of the DAOs fail because they fail to do one of the things that I'm describing out of usually selfishness. It's like they don't allow themselves to be decentralized because as they're building it, they're like, you know what? I own this. Why would I give away power in this DAO? And so it turns out that almost every blockchain connected organization is actually quite fundamentally centralized. And you look at anything, as we were criticizing, what was it, Tether last week, it's perfectly owned by a corporation. Okay, it's completely centralized, and yet they're doing this fake blockchain for show stuff, but they're actually not anonymous, they're not autonomous, they're not open. They control it, and so it's broken from the beginning in some sense. So decentralized solutions will beat it, or else all of the system will collapse. If you're not going to make it decentralized, there is no point of using a blockchain, because blockchains are redundant, slow, expensive, right? They're and energy wasteful. They're just a terrible system to use unless you want it to be decentralized. So if you're going to control these things, you can't own them. You can participate in a network, and you can gain power in the network by honest help to the network, but you shouldn't own the whole network, or else it's centralized. Okay, and then there's 0 point in participating in it. You should go to a centralized source that's not got the blockchain redundancies. You should go to Google or other centralized places. You should not buy and use these systems, because they're not going to be as cheap here, and they won't be as good. Okay, so one other aspect of this is, if you'll notice that you might want to think about how this is an evolutionary platform, that the each component drives the other component to get better. You know, that when you're looking at the wherever this last piece is, yeah. The evolutionary platform is in some sense thought of seeing this as a dynamical system here, that improvements in the forum encourage the public to use the forum more often, to engage the bench and pay them fees, and the fees encourage the bench to do a better job, to create more posts in the forum that are good history, as well as better smart contracts that the public can use. And so this cyclical property of the nature of this whole thing makes for a positive feedback loop that keeps encouraging everything to get better. If it's working, you know, if it works, it's gonna continue to improve how it works. And that's really essential in game theory, to make sure that this system stays dynamic, to make sure that the bench is always improving the forum, improving the smart contracts that they're using, or else it's going to collapse, because any static system that has a single algorithm to describe how it's going to work is eventually going to be beaten by the enemies, especially if the reputation tokens are actually ever worth something. Well, then there's a strategy that somebody can come up with that can gain a few reputation tokens and then take value out of the system. So that's a game theory result that I can talk about in a later lecture on a different night, when we actually, if you want to talk about game theory. So it's a whole different mathematical field, that's very applied math field, that's extremely relevant to any sort of systems thinking that we're engaged in right now. Okay, I got through that faster than I was afraid of. We could talk about how it's secure against Sybil attacks, but that's why so many of the choices were made, is that everything's weighted reputational choices. Like when you get engaged for a contract, that's why the availability stakes should be randomly chosen based on how much you add. That way, if I have 10 different accounts with one reputation token, I'm going to have the same likelihood of getting a job as one person with one account who has 10 reputation tokens. So if I split my reputation tokens into different accounts, that doesn't change my likelihood or how often I will get a job. So just as a for instance, but everything was carefully designed to make sure that Sybil attacks do not affect it at all. And the other question about the other security attacks are enough, we can talk about those too, depending on what you come up with. Okay, any other comments or questions? I think we're done with this stuff. Oh, I had a few other consequences here. When they're talking about proof of stake algorithms that the networks the blockchains are trying to come up with, they always have a lot of problems with centralization. There's these things called delegated proof of stake. That's where a bunch of delegates offer their stakes and other people vote on whether or not they should do it. They're always based not on reputation, but on money directly. And so proof of stake just doesn't work very well when money is what the stake is. It's very easy to attack a proof of stake network by just owning a bunch of stake. Okay, then you can take over the network. And so the reason that Ethereum has been trying to go to proof of stake the entire time it's been in existence, and it still hasn't, even though it's missed many deadlines that it promised it would make, is partly that their proof of stake is based entirely on their money of ether is determining what your stake is. You should really use proof of reputation. Okay, that reputation is a more valuable thing that stays secure in the long run. It motivates people to behave well in the long run. And so a lot of the problems with proof of stake are taken out by proof of reputation. Another aspect of this that's not included but can be automatically built in is, at some point, what if the customers and the workers disagree? They have a problem. I said I brought them there, and then the customer said, yeah, no, he didn't bring me there, he never showed up. Well, what's going to happen? How do we do this? At some point, you can add more complicated language into the business smart contract that allows either party, the worker or the customer, to trigger a dispute resolution issue. You can trigger an arbiter, a third-party arbiter, to get the power over the smart contract, and then they can create a new smart contract that allows the arbiter to take control of the money that was in the other smart contract. But that has to be built in from the beginning, or else you can't have dispute resolution in this thing with anonymous members. And that allows appeals to whatever you're going to do in any situation. So you can make a more complex structure just by adding more smart contracts to this. And you certainly would if the DAO got it all valuable and got it all useful. And so basically I was trying to go through how this is applicable to the gig economy, for instance, and any type of job is addressed here, and et cetera. It's the Oracle problem is a fundamental question in this stuff. We can still use the same thing. Your reputation you can grow for oracles. Any job you want to make that's decentralized can follow this basic architecture, and we can create a DAO that does whatever job that the people agree to do. And so for us, however, we have an issue for our chit fund. The chit fund is very complicated, much more complicated than what we talked about here. And the reason I encouraged you from the beginning to look at the chit fund, however, is because it's going to address all this stuff and new things. So another week I can discuss how you would deal with what's called, well, basically insurance, or what's called underwriting in finance. So underwriting is the same thing as insurance. It's like you're promising, the insurance company underwrites whatever claim you sign. Like they underwrites that you're going to get paid if your house burns up, okay, if you get fire insurance. And so underwriting is a very important thing in finance. And it's a complicated extra piece that how do you make decentralized underwriting? And that's effectively what the chit fund manager does right now. And so how do we underwrite these chit funds? How do we make sure that the people who join them are going to be made whole in case somebody quits? And so that's an extra layer that you might want to consider if you want to make a truly sophisticated chit fund DAO, is how are you going to make insurance so that people will actually want to do it? And reputation is at the core of how you will make sure that this is going to work, that you want to actually make sure that reputation is valuable. And then when you have this valuable reputation, you can use that for insurance. Okay. And people will lose reputation and not actually money if something doesn't go according to plan. And so seeing how that all works is not enough. That's too much for tonight, but we'll talk about it later if people are getting this one. If not, we can go over more of this how to build a DAO thing another time, and I can answer any other questions. So that's been an hour and a half. We'll take a break, but first, anybody have 5 minutes of questions or anything like that before we take a break? Okay. Well then, let me take a break on this.
All right. You guys can hear me fine, right?
Yep.
Perfect. Okay. Just give me a second. Can you see my screen?
Yep.
Okay, perfect. So today I'm going to be presenting on OpenZplane. I think that's how it's called. Correct me if I'm wrong. So let's get started. Contents I have today are introduction to OpenZplane, contracts, fungible and non-fungible tokens, ERC20, constructing an ERC20 contract, ERC 721, constructing ERC 721 contract, access control, ownership, and ownable, role-based access control and using access control, and then utilities. That's what I'm going to present. So what's OpenZplane? OpenZplane provides, it's a library essentially that provides a complete suite of security products to build, manage, and inspect all aspects of software development and operations for Ethereum projects. So essentially, it's a library already equipped with smart contracts that can do a lot of things for you already built. And I think that's what the professor was talking about when we began the class, that there are certain things that are already built that you don't have to build from scratch and induce the risk of making the mistake and programming something that could break your smart contract, essentially. So OpenZplane provides that well-written and tested library for you. A bunch of things that OpenZplane, major things that OpenZplane provides are contracts, library for contracts, library for upgrades, and library for security ops. And that one is called Defender. And upgrades are essentially libraries for tooling and scaling and all that stuff. While Defender, like I said, is a library for security operations, essentially securing your smart contracts. And then the contracts library is made of reusable code, reusable contracts that you wouldn't have to, repeatedly write to use. And and they're all written in Solidity. So contracts contain, like I said, we'll be focusing on contracts in this presentation. Contracts contain a library for secure smart contract development built on a solid foundation of community vetted code. So you have a bunch of people, a community, it's open source, I think, vetting the code and testing the code and making sure that everything is okay. So contracts provide implementations of standards like ECR20, ECR 721. We're going to dive into that in this presentation. Flexible role-based permission and scheme for your contracts and reusable components to build whatever you want to build in Solidity. So let's start with what fungible and not fungible tokens are. We'll start by defining the token because a lot of people don't have a misrepresentation of what a token is. So a token is a representation of something on a blockchain. It could be money, time, services, shares in a company, a virtual pet like in the metaverse. And by representing this things as tokens, we can allow our smart contracts in Solidity to interact with them, exchange them, create and destroy them. So there's a big difference.
Quick question.
Yes.
The actual cryptocurrency is that a token? Is that an instance of a token?
Professor, do you want to answer that?
Yeah,
I don't want to give the wrong answer.
sure. The Ethereum token is just a token. A Bitcoin token is just a token. But on the Ethereum blockchain, the Ethereum token is the basic token that runs it and is worth money. Now, what it allows you to do is pay for gas, which is what allows you to pay for smart contracts to be deployed and motivate the miners to deploy your smart contracts. But the Ethereum token is just a token, in the same way that you make other tokens, but every other token means something else. You can't just mint Ethereum tokens in the way that you can mint all the other ERC20 tokens or ERC471 tokens. So the ERC20 tokens are tokens that you can just make up, like the reputation tokens I was just describing. You can have a smart contract make as many of them as you want, and they are recorded then for all eternity that these are those tokens and these are the people that own them. Maybe a smart contract owns them, maybe an actual externally owned account owns them. But again, so that's the general notion of an ERC20 token. Is that cool, or is there any questions about that?
Well, just to summarize, I would say that Ether is a special token and it has very specific rules governing it, how it's created. And the other tokens, yeah, it's wide open.
Well, yeah, you can be much more creative in inventing new tokens anytime you want. But like from a philosophical point, they're all the same. An Ether is just a smart contract, because a smart contract is just a programmed contract, right? It's just a program. And so the Ethereum smart contract that governs the entire network is a smart contract, and the Ethereum token is just one of the tokens that's made by that smart contract. So it's definitely a special token. And so is Bitcoin a very special token, but every token's special. It's just whether or not people care about those tokens. So sorry to get philosophical about it, but they're all the same, right? They're all just programs and digital pieces of code. But yes, Ethereum tokens are very different than the ones that I make up with any smart contract I want to invent. But not,
okay, very good, thank you.
Not actually, right? Like they're all just programmed. They're all equivalent in that sense. But the only reason Ethereum tokens are worth money, the Ether worth money, is because people think they're worth money. And so the same thing with the tokens we would invent is those reputation tokens I just discussed would be worth money if people thought they were worth money. And that's where you want to make sure that your reputation tokens actually mean something in a DAO that means something, and a DAO that actually achieves something.
So I would say interest drives the value of the token.
Yep, whether that's Bitcoin or whether that's the made up ERC20 token that you just made up today, right?
So if we make a token, it could be worth 0, but 5-6 years from now, it could be worth $1.
Right. When you make it, it is worth 0 because
yeah,
that's a fact. Yeah.
Okay.
But it can gain value if it's connected to something meaningful that people care about.
Like a meme or a joke.
Right now, that's what Say's just explaining right now. I think he's going to get to is these non-fungible tokens are for that. And that's a different ERC standard.
Yep. Okay. Should I continue?
Please. Oh,
Perfect.
who else has a question?
So yeah, so the way when I was researching this, the way where I got this information from described it as you have 2 voting rights, and they're the same, they're equal to one another. But if you have a house, you have 2 houses, they're not the same because the dates are different, they're 2 different things. So that's what fungibility is called, how you could exchange it for one another. Could you exchange it? The exchange is it the same thing when you exchange it, essentially. So fungible goods are equivalent and interchangeable like Ether and other currencies and voting rights, while non-fungible tokens are unique and distinct, such as deeds of ownership, like your car title, for example. It's very specific because it has a VIN number and all that stuff, and collectibles such as heart and all that stuff. So when you're dealing with non-fungible tokens, you care about the ones you have, while fungible tokens are how much you have. So that's like Ether and all that stuff. So ERC20. So an ERC20 token contract keeps track of fungible token. Any one token is exactly equal to another token, like a voting right, for example. And no tokens have special rights or behavior associated with them. So this makes ERC20 tokens useful for things like medium of exchange currency, voting rights, staking, and more. So Open Zipline contracts provides many ECR20 related libraries and smart contracts. So on the website, you'll see more API reference for such contracts, smart contracts. So I'm going to show an example of constructing an ECR token contract for an hypothetical game where you could use gold as the currency. So yeah. So this is an example. So you have a Solidity contract here that we talked about this. This is a relationship inheritance, and it inherits the ECR20 contract. GLD, which is gold token, is an ERC20 contract. And you have the constructor for the initial supply of gold. And I think this essentially constructs, gives the currency name and then the currency unit, I guess. And then the methods that we have, functions that we have for the user. This is the message sender, and initializes it with the initial supply and mints this gold. Right? I think that's what this this contract does. And so yeah, that explains it here, which is contracts are often used through inheritance. And we're basically reusing the ERC20 for both the basic implementation and the name symbols and for decimals and all that stuff. And like I explained, we create an initial supply of the tokens, which would be assigned to the address that deploys the contract. I think that's what this is doing. So yeah, so that's a sample right there. This is the usage. Would you use this contract that we created? We can check the balance of the deployer address. If you have, that's a lot of zeros right there. And you can also transfer it to other accounts. And you could also check the balance of this gold token on other addresses. So you transfer, check the balance, and you can also check your balance you have left from. So essentially you're extracting from your balance, transferring to a different address, and then you're checking your balance. And yeah, that's what this is doing essentially. So we move on to the ECR 721. We talked about the ECR 20, but what if your tokens are not alike, like we described? These are the non-fungible tokens, such as collectibles, real estate, and all that stuff. So ECR 721 is a standard for representing ownership of non-fungible tokens, which means each token is unique. The second point essentially mentions that ECR 720 is more complex than ECR 720 with multiple and optional extensions split across several contracts. So constructing an ECR 720 token contract. So in the hypothetical game, we use ECR 720 to track items in the game, which have their own unique attributes that can be awarded to each player. It's going to be minted and sent to them. So players can trade their tokens, and yeah, they can essentially trade their tokens with other people and give them out. And we're going to show that how we could construct that using the OpenZipLin library. So essentially, we have game item is this contract right here is essentially saying that this is going to store the uniform resource identifier of the token, and it's going to be using counters. Counters is also a contract that is used for increment and keeping track of things by incrementing them by one. And this is the constructor, game item, that's the name of the token, and this is the unit of the token, I guess. And we have a function which is going to be awarding items to a player, which would take in the address as a parameter and the token URI as a parameter too, and returns this data type right there. And it's going to increment the token ID to keep track of each token. And yeah, so this is going to assign it to the new item ID and mint the new item by passing in the player address and the item ID, and then set the token URI to the new ID and then token URI essentially, and then returns a new item ID to back from this function. So yeah, so this explains it. That question?
I got a question. Yeah. So the counters, is there a counter that is going to be unique to this contract that you're creating, or it takes a counter from one of?
It's going to be unique to this contract.
So pretty much, if you just start, the first one is going to be like the first item that you're going to give for ownership.
Yes.
And then have one.
Yes.
Okay.
Yes.
To add to that question, is that it has a relationship to the supply we have of the newly tokens we created, right?
Supply tokens.
Yeah, the
Oh,
counter interacts with that supply. Because we need to, if we emit in tokens, we need to know how much we have left.
Yep.
We have a limited amount.
Of what?
Of the tokens. I mean, I think ERC 721 is different, but I was talking about the other ERC 20, I guess.
Are you talking about this one?
Yeah, because we set up a supply for this.
Oh yeah, yeah. So
right?
So you can tie them together. That's if they're under one. They're interacting under one application. You could sort of tie them together, but right now there's no relationship between the two. I'm just using this as an example, if that's your question.
No, I was wondering if the 721 type has a limited supply, or if it, because we talked about supply, right, for the other tokens, but I believe that ERC 721 does not have a supply limit or anything like that. That's what I'm asking.
Oh, I'm not sure. I'm not sure about that. Supply in terms of the storage unit or what?
No, how much tokens we have available.
Oh, okay. I think you can create as much tokens as you want if you're minting new tokens. So you can create as much as you want if
I guess based on the data type of counters.
Yep.
Probably.
Exactly.
It's probably some giant number. I have actually a follow-up question. So when we create a token, we do gather the metadata for whatever item. But
I'm going to get to that. I'm going to get to that.
Oh, okay. Well, then I'll ask later. Right.
Okay, perfect. So if you have any more questions, then you can ask me. So essentially, what the U72, like I explained, is it's storing the metadata. It sets the standard for storing the metadata for the ERC 721 storage that you are token that you are essentially making, right? So it's a mechanism for storing for token metadata, and this is the function essentially you call the method. This is object oriented. The method that you use to store the items metadata essentially. So we're going to see this in the next slide how you use this. So constructing it, how you use the stuff we constructed here. for a game. So if you win something, for example, in a game, and you want to award the player, you pass in the player's address, and then you pass in the URI info of the item they want, right? And if they want to query that item, you could just say owner of 7, and then the 7 essentially is generated by this counter, right? So that's essentially what this does. If you it transfers it to the blockchain, I think that's what this does. And then if the owner queries that item, owner, it returns the player address, and it returns, if you query the token URI of that item, it returns the URI essentially. So inside that URI, if you go into that JSON file, it's going to show this. So for example, in the game, it's like, this is just an example. It's a game that rewards you with Thor's hammer. So this is the name, description, and then stores the image, and then the strength of the item. So I don't know if that was your question, Arthur.
My question was, so let's say you have Thor's hammer here.
Yep.
It's non-fungible token. What
Yep.
stops you to register it as a non-fungible token somewhere else?
That's
Exactly
interesting.
the same thing.
That's an interesting question. I think that would have to deal with our blockchain, Ash's information, because if you register this somewhere else with the same information and you ash it and do all the ash functions and all that stuff, I feel like it's going to be the same. I do not understand that complexity in depth, but I'm pretty sure that's why you can't have a duplicate, right? In the
So pretty
blockchain.
much if you change one thing, then it's already,
Exactly.
it makes
Exactly.
it a new item then.
Exactly.
But go ahead, Arthur. I was gonna just add to something important, but yeah, I'll let you finish.
I mean, if it's if it's the hash, then you can throw in something after strength. You can do something like a line bonus attack +5, something like that, and that will change the item. But in the sense, it's going to be the same thing, kind of.
Yep.
I'd like to address it. I don't know if I'm going to help or not, but
yeah, address it, sir.
So if you take the exact same item with the exact same details and it has the exact same hash, you can repeat that exact same item anywhere you want that's on a different program, that's on a different smart contract, it's on a different platform, a different DAO. Then yeah, so one DAO that records all these non-fungible tokens, these NFTs, for a certain number of game items, will have just unique 721 tokens for each thing. And then on that DAO, it's unique. You can't replicate it if you choose not to replicate it, if you put those instructions in your 721 contract. But that doesn't make it true. Same as the tokens we were talking about, the ERC20 tokens, when you were asking if they were worth anything. Like in the beginning, they're not worth anything. Well, so this 721 token on one DAO can be repeated on a different DAO, and there's nothing to stop them from copying it and putting on a different DAO. The exact same information, the exact same PNG file, right? That same picture file that is in this image can be sent, and this can be copied and put on a different DAO, and then somebody has Thor's hammer on a different game. And so just because you own it on one game or one platform doesn't mean you own it on the next platform. So it's the platform that determines whether it's valuable. And the platform is whether or not the network is powerful, whether or not people are using it, whether or not people want to use it, whether or not people pay money to use it, right? and again, that's the level of thinking that might, I hope that answers your question.
It actually helps, yeah. So it's within the context of the DAO things. It's like a mini universe.
Yep, then it's
And
unique
if,
there.
it has enough people who are interested in there and involved in there, that makes it, that item, that universe, more precious than, let's say, the same item but in the app where only 3 people participating. Like, who cares about that?
That's right. And that's what makes people sort of incredulous about the fact that people pay millions of dollars for an NFT on a platform that just started this year, when somebody else can clone that platform and run it a copy of everything they did and sell it again on a different equivalent platform.
But you gotta have Gary Vee supported though.
Yeah. And
Yeah.
mostly you need a network. You need a bunch of people who care, who are all
Well,
participating in this.
Just one little short example. I don't know like how many people follow it, but the thing that Gary Vee did, it's just amazing. He knows a bunch of bloggers that have millions and millions of people worth of audience. And instead of talking to millions of people, he got 7 of them in one room and told them, this is the platform, these are NFTs, you know me, I know this stuff, we gotta buy those. And that's how they just blew it up, because they mentioned it on their channels and they got millions and millions of people pouring in.
They made it valuable essentially.
Yeah.
Well, he bought few of them first, and then he made it valuable.
Right.
Yeah, but they're powerful. They're powerful people with money essentially. So it's like
They have reputation tokens measured in the the number of subscribers.
Mega influencers.
Yes.
exactly. That's it.
So that's a really important fact, there's a fundamental fact about this that has to be understood deeply when you're trying to make this, is that you can't build a network from scratch. You can only ever cannibalize a network. And that's what he did. He took a network that already exists and brought them over to his network, made them participate in the new network that he invented. So new networks don't just come out of nowhere. They have to have an existing network that already exists, and you need to convince them to go to the new network. You can't use word of mouth with your friends to do this. You have to participate in networks. That's why one of my instructions for this class was join a network. You need to understand the network in order to cannibalize it, in order to, and the word cannibalize is a little tough, but it's like a technical term when I'm just describing how they took over a network, right?
So, Professor, when you say network, you're talking about, can you emphasize on that? Sorry, I'm kind of lost.
Say again, I missed the...
Can you emphasize on the network? Because I'm not sure, because you said you can copy the network. Which network were you talking about?
I'm not sure when I said copy. Right now I was just talking about
No, not
cannibalizing.
copying, sorry. I mean, like you said, cannibalize.
Oh, for cannibalizing the network?
Yeah, so which network are we talking about here?
network of people
Yep,
essentially.
any network.
Oh, okay. I was
Yep.
thinking of like the system. Okay.
Good
never mind.
point. Yeah, that's a good clarification. No, I mean a bunch of people who are all acting.
The
in
network
concert.
of people. Okay.
Yep.
And that brings me back to my question is like kind of like I'm confused about this NFT thing. So if I create an NFT, I'm the first one that created it. I own it, the rights to it, right? I'm the first owner. And that means I can transfer ownership to someone else who, I mean, that person, if that person pays for my NFT, that means I have to transfer ownership to them. That means I no longer own it. But what you said about what's happening is completely different. And I had an idea about it. Now I'm kind of confused. How do we protect the ownership if we can copy these things? Or we can't, I guess.
Well,
I think it
that's-
depends.
Oh yeah, go ahead. Sorry.
Sorry, yeah, just something to add before the professor goes. I think it depends on the platform, like the professor said. If your network is powerful enough and you have your artwork on a powerful platform, it's unique on that platform. But if someone else takes your artwork, for example, digital stuff, and mints it on a different network, it doesn't stop anybody from buying it on that network and saying that it's theirs and making money off of your work. So it depends on the platform you put it in, essentially. That's my perspective.
You're totally right. So, but if I copy it, to a network that was just created yesterday, no one's gonna care, of course. Even if they look at the same item, they say, "Well, this was created yesterday." That means it's just copied. It's like about repetition, I guess, right? Building repetition for your platform.
That's right. Well, I just want to say something obvious too, is that the reason that you can't copy it on the same network, like these ERC 721 tokens, when you're on one network, you can't duplicate it on one network, because once you sell it to somebody, you no longer have the public key, private key, you no longer have the private key ownership of the address for that token. So you can no longer interact with the smart contract that would transfer that. Whereas the person you transferred it to gets the new public key. So they control the token after you sell it to them. So if you sell it to them properly with a message that which transfers, a transaction that transfers the ownership, then you no longer own it. Even though you have a copy of information on your hard drive, you don't own it, and the network recognizes that you don't own it anymore. So you can't do anything with it that the network will recognize.
That clears it really well. Thank you. So ownership, matters only within the DAO.
Yep.
But yeah, so if I would want to copy this, I need to create an entire new DAO and just promote it. And good luck. Who's gonna follow and believe in that?
That's right.
So yeah,
it is possible to look at the time at which somebody acquired ownership of it and see who did it first, isn't it?
Yeah, and that's the cool thing about the blockchain is that anybody in the world can check that, and if you are correct, then you have some justification that people might believe that that's more valuable. But if you're still not on the important network, you're not on the important network. So it's a matter of convincing
So
people.
it's a matter of what everybody believes is the authoritarian network,
right?
And that's when everyone will believe, and no matter what,
and desire. And it's not about belief, right? That's the whole point of code is law. There's nothing to believe. There's no laws. You're not used to understanding. Well, there's nothing to understand with code is law. The program does what the program does, is what that's supposed to mean. Axel really gave, in my opinion, a skewed vision of code is law. That for me, code is law means what happens happens. And so there's no understanding, there's no belief. It's just, well, what do people do? What do people trade money, valuable tokens for? Ethereum is valuable because people trade dollars for it. That's why it's valuable, not because it's anything except digital vanishing information that shimmers around. Right? So there's no inherent value to it. There's no physical value to it. There's no material value to it like gold has, but it still has value because it's very, very stable in the sense that blockchains are stable. Even though they're made out of digital, electronic, shimmering things, they're going to be stable because millions of people are using it and all doing the same thing. They all have consensus. They're all repeating the same thing and they're all in agreement.
So here's a situation I just thought about, when we're dealing with NFTs. So, okay, let's say I'm on the same network, right? And I just joined this new network and I just see this cool digital art that was just dropped there and it's worth $1 million. Okay. I took it, I copied that PNG, took it to my Photoshop, did some modifications, some major modifications. It looks different. And then I created a new NFT and I put it on the same network. I mean, here I'm still breaking the copyright laws because I copied someone's work. I still did a little bit editing, but does the system as a blockchain protects people from this kind of acting?
It depends on the DAO. If the DAO has standards where they would kick that information off or destroy your work after you've done it to delete you, then the DAO does that. If the DAO doesn't do that, then it doesn't. And
Yeah,
so
and
there is no law. Like these blockchains are supranational, so there is no jurisdiction that governs them. Bitcoin is violating European law right now in many different ways that is contrary to their law, and yet Bitcoin is still going to do what Bitcoin does, and they either accept it or don't.
Well, yeah, but
so here's Osama. Here's how I understand NFTs. So yes, you can be on the network, but also whatever you're presenting as your work, art, you have to have a reputation to set a value. So even if you very strongly modify the original NFT and you put it out, it doesn't mean that that's going to sell for 1 million because the original NFT that was sold for $1 million is based on whatever reputation the original creator of that NFT has. And
So yeah, so
you
it's
can't
the
you
repetition of the artist.
you can't just like like I think that we were talking about that reputation thing like earlier about you create like you have to gain value, you have to be like you have to have a following. Basically, you have to have a reputation, like, to put it simple. And when it comes to like why there has to be a network and stuff, like think of like autographs, right? Autographs and stuff that are sold, that is like physical thing. There are ways to validate those autographs. Like they're like people, when people say, oh, this basketball was signed by Michael Jordan. They validate that it was actually signed by, like, there are services that you buy to validate that it was actually signed by Michael Jordan, because actually there are, like, people who can, like artists and stuff, I'm sure they can just like kind of like look at similar or exactly like Michael Jordan's handwriting. You know what I mean? But there are like people who actually there are services that you can hire that will validate the autograph of Michael Jordan. So it's like similar to that. You can't just like to your earlier point of like, can I just copy and sell it somewhere else? It's similar to that. That is like there's going to be a validation of that work. So it's not going to be. It's essentially like a piece of art. It's a piece of Bitcoin. You can't just like say, oh, well, I have a Bitcoin, and then try to sell it. Like there's like rigorous validations, rigorous like checkpoints, and checksum and all that stuff, authentication that happens for you to claim a Bitcoin. So it's like that. That's my understanding. I mean, somebody could correct me if I'm wrong.
No, it totally makes sense. Yeah, I was just, but there is possibility that I can get inspired from someone's work and get something really similar to it, but it winds down to my reputation as an artist and how much people like my work and how much value they will put on it, I guess.
Yeah. Yes. Also, like there is like a when people create NFTs, that they create like, I don't know, like almost like hundreds of variations of one NFT. So it's I mean, it's, again, like you can super edit it and stuff, but still like the value is not going to be there because you're not the artist. I mean, you will receive lower value, way lower value for your art.
Yeah. And if you sell things on this websites, right? Because I've forgotten the website's name. There's a famous website that sells NFT hearts. There are also human factors that deal with this website. We're talking about things in the blockchain level, but if your stuff exists in the blockchain but is not listed on the website, you can't sell it. So if someone reports you for, oh, this is copyright, right? They're gonna kick off your stuff off the website, and you're not gonna make any sale. So it's not only the solidity part, the blockchain part that exists in the as a factor in selling of these things. There exists a human aspect that inspects and verifies and all this stuff too. I think that's another perspective to it.
I have a question. Maybe my understanding was wrong, or the way I understood it was once you have this NFT, it is tied to some key, right? Some hash key that is created by using your own public key and some combination. So that is going to be unique regardless of what network that it is created after that. That it would be the only one in existence. That was my understanding. So regardless how or where you created again, it is kind of impossible to have that same key, was my understanding. Was I wrong?
I think so.
So that validates that. Okay.
Yeah. See,
tell me.
Your public key, or sorry, your private key of ownership of your NFT on one network is not going to work on a different network. On the different network, they will generate a new key for whatever new things happen. So you can't use your public key from one network and one token to use it on a different network.
Yeah, but let's say my key is XYZ, and I have published, and I've said that this is it, XYZ, and then regardless, nobody is, it's kind of impossible, nobody else to come up with XYZ for that, because that's going to be unique, that's going to be mine. So it's always going to be me. I am the first one that came up with XYZ, and nobody can produce XYZ
on
ever.
that network. That's what we've been talking about.
No, even in another network, because to come back with XYZ, you have, let's say, to concatenate 5, 4, 3, 2, 5, 7, what, those certain things, right? So it's kind of unlikely that somebody have that, 3,000, characters concatenated to come back with the exact sequence to come back with XYZ. So I would be the only one with XYZ ever. That was my understanding.
That's true. And maybe you could then go to a different network and create that token on the other network with your private key.
But it's still not going to be XYZ. But it's still not going to be XYZ. It's going to be different, right?
Well, you could, if you have XYZ, if you have the private key, the signature that allows you to demonstrate you own it on one thing, you could technically go to the other network and recopy it there if you invented it there. But this is a weird thing to even talk about.
Okay.
I do want to mention one last thing that we've been skirting around on this ERC 721 tokens is the value of them. Like, why do people care about them? Why are they paying $1 million for a PNG file? And it's basically that the blockchain network allows the most sophisticated provenance technology that has ever happened. So provenance, the word, is something you really have to understand the value of these non-fungible tokens.
You say providence?
Nope, not provenance. Provenance, Provenance, and that is the history of an artwork. So when we study Rembrandt paintings or some classic master, and I want to sell you a Picasso painting, for example, in the alley, and I say, here's $1 million, give me $1 million for this $10 million Picasso painting, and I'm in the alley, well, you shouldn't pay me, right? Because it's most likely a copy. But if you can find what is the history of that painting, the history of the ownership of who owned that painting all the way back to Picasso, then it's much more valuable than if you just find a very nice new painting that somebody had in their garage that looks like a Picasso. The provenance is that line of history that explains the value of that work. Well, blockchain ERC 721 tokens have the most perfect record of publicly available, transparent, anyone on the planet can check the provenance. And it is absolutely certain on the blockchain because it's checked with open, transparent, immutable, uneditable network that millions of people are maintaining. And so the provenance power with the ERC 721 tokens is so much stronger than the provenance power of human systems any other time in history. And that's what's driving this, is like people are realizing this is a new way of ownership, a new type of ownership. By the way, much as I hate ERC 721 tokens and I hate NFTs and what's happening, I can recognize this is powerful new technology that is going to make an effect on the way we do economics if blockchain survives at all, if peer-to-peer decentralized thinking does work.
Thank you, Professor. Yeah, so I'm going to continue. The next feature that contracts in the OpenZipLin library allow is access control. Another feature of it is essentially was allowed to do something, right? it's very important in the world of smart contracts, essentially giving authority to someone to create, delete, modify, update, retrieve a certain piece of information concerning a contract or a token or anything like that. So the access control of your contract may govern who can mint tokens, vote on proposals, freeze transfers, and many other things. So it's very, very important for you to understand how to implement it, or someone steals your entire system. So we have ownership and ownable contracts. So the most common and basic form of access control is the concept of ownership, and it's essentially an account that is the owner of a contract can do administrative tasks on that contract, and it's an approach that a lot of contracts use for single administrative users. So OpenZipLink contracts provide the ownable contract for implementing ownership on many various contracts. So we're going to show how that works in code. So ownership and ownable. So for this code, we have a contract defined as it's ownable, and you define a function that essentially can be performed by only the owner of that contract. So this is a special thing that only the contract can do, only the owner can do, and only the owner of this contract can call this function, essentially execute the function. And as you can see, there's a difference between the signature of these functions. One as a only owner in front of it, and this just as a public. Okay, so anyone can call this one, while only the owner of this contract can call this one. So this essentially explains it. Another thing ownable allows you to do is to transfer the ownership from the owner to a new one, and also renounce the ownership. And this will essentially just stop this function from functioning, essentially. And you wouldn't be able to call this anymore. If you try to call it, it wouldn't work. So that's what this explains, that removing the owner altogether will mean that the administrative tasks are only protected by only owner, that are only protected by only owner would no longer be callable. So if you renounce the ownership, this is going to be obsolete. Okay. So role-based access control also exists. So for this one, you would, sometimes want to specify certain roles can access certain contracts and certain functions in a contract. This is what this does. So you can have a moderator, a mentor, or admin roles. And instead of having just simply only owner, and this check can be enforced through the only role modifier. And we're going to show that. So this last bullet point essentially just explains that various softwares have different roles and to perform certain tasks. And that's why we use this in Solidity. So using access control. So OpenZipLink contracts provide access control for implementing role-based access control. And it's very easy to use. You just define a new role, create a new role identifier, and you can use it to grant, revoke, and check if an account has that role. So we're going to show that. So this is it. This is an ERC20 contract, a contract that is a token essentially, and also is has access control on it. So this is a role, for example, a mentor role, and this defines the constructor of the token itself, and it sets up the role and as a function for minting, and essentially just says you have to requires that it has a mentor role, and if it doesn't, it's going to send back this message that the caller of this function is not a mentor, does not have this role. So I'm not going to allow you to use it. And if it does, it's going to come here and mint and send that amount to this certain address. So essentially, this describes that it allows you to the accounts that have that role to create new tokens. This is essentially what this code does. So the last one we're going to talk about is the utilities that OpenZipline provides. So it provides a lot of useful utilities, and we're just going to run through a bunch of them. There's a lot. You can go to the website to look at that. So it has one for cryptography, checking signatures on the blockchain. So that's what this one does. Yeah, that's one of it. The second one would be verifying Merkle proofs that we discussed in class, and that a certain value is part of the Merkle tree. Another one is introspection. Essentially, you're checking for the functionality of a contract with this type of library, with this type of contract. You're checking for the functionality that does it support this, that, does it support a certain standard, does it support this, does it support that. So it's used for runtime interface detection. So if you are familiar with Java, this is sort of a reflection for Solidity programming language. So it's used to manipulate things real time and inspect things real time, contracts real time. And you also have the math util. Every library should have a math util, especially Solidity, where you're dealing with payments and numbers and a bunch of things. So you can, use this to a contract called save math to add numbers, subtract, divide, multiply, and modulo operation. You also have payments, which would allow you to do a split in of payments. I believe this is what this websites use that sell collectibles. Essentially, you would have like a certain percentage. There's some website that has a certain percentage, even though the original creator of that collectible is not in possession of the collectible anymore. But there's still a certain percentage that goes to the original creator and when a sale is made. So I believe this is what you could use to create a contract like that. So you have collections. We all know how powerful collections data structures are in computer science and programming. So this library provides you with that, a set, a map. And then you have MISC for different things. If you want to check if an address is a contract, you could use this this function right there, or method, whatever it's called. So we also, this also mentions counters. We saw how counters work in the first contract that I showed, essentially incrementing the number every time you use it. So this is what that does. And that's all for tonight. You could check this out in the docs.openzipline.com. I can upload this to D2L, the presentation, if you would like me to. And that's all I have tonight. Thank you very much.
Excellent. Thanks very much. See, any other questions for him? Okay.
Right.
Yep. Thank you. So is there any business for tonight, or are we finished for the evening? Anybody need any conversation about what the future of the project's going to do?
That might be good.
Okay.
Don't exactly have an agenda.
Sounds
for that
good.
discussion. Yeah.
Okay. Well, hearing nothing else, I'm going to at least